Okay, we're going to be doing a few more sorted problems. We're going to use the same strategies that you've seen in the prior videos. So here's those strategies again. The one problem I'm going to do today talks about having an open box, and you can't really see the box, but here would be the base of the box, and then they've cut away these squares here. So what that does is it creates a length of 24 minus 2x, a width of 24 minus 2x, and then the height of this would be x itself. So the height is x. The way we can compute the length and the width given whatever certain height we're trying out is just by plugging in that height, because we call the height x. So we'd plug in 1, and we'd come up with the length of that and the width of the box being 12. Then we plug in 2, and well, that wouldn't be 12, that'd be 22, excuse me. Then we plug in 2, and we'd end up with 20 for our length and our width. So really what we have inside of here for this volume is we have 22 squared, and here I have 20 squared. So while this doesn't look like the volume, this is the height, and then this is the length times the width because of the squared part right here. So we're taking the length or the width of the side, in this case squared, and that gives us our answer. So when I continue on with this process, and this is the long way of computing this is just doing it by hand, I get 18 for my length and my width. So my volume would be 3, the height, times 18 times 18, and I'm writing out a little bit differently. I think it looks less confusing than what I had typed in there. That ends up giving us 972. I'm going to plug in 4, and I end up getting 16. And then so I have my height is now 4 times my length and my width are 16, so 16 times 16. That ends up giving me the answer of 1024. And then I've got 24 minus 2 times 5. And so that would give me an answer of 24 minus 10, which is 14. So I'd have 5 is my new height, times 14 times 14. And this gives me the answer of 980. And then I'd plug in 6, so I'd try 6 for my height. And I'd end up getting the answer of 12. Each time, notice my length and width are getting smaller because my height is getting larger. So I end up getting 6, my height, times my length, times my width, which ends up giving me 864. The whole point of doing this chart was to show you that you could actually figure out the maximum volume if you were talking about whole numbers and you only had to check whole numbers, and you could do that longhand. I found out the maximum value would be 1024. Now, we could do it that way, or we can compute using the calculus problems, or the calculus method. So what I will do in the next video is show you this exact same problem using the strategy that we've talked about in this section so far. The video you just watched, I showed you how you can use a table format to find the maximum volume of an object, but now what we're going to do is we're going to do that same problem, and we're going to use the calculus portion to be able to do this. So we're going to write the volume as a function of x. That would be part B. So V is going to equal, remember, it would be length times width times height is the volume formula. So V is equal to, the length would be 24 minus 2x. The width is 24 minus 2x. And the height is x. So what I'm going to do is actually go ahead and write this as x times 24 minus 2x squared. And I will go ahead and take this derivative. So use the calculus to find the critical number. So that means find the derivative of this. The one thing that people like to do incorrect is to use chain rule on this, and this is not a chain rule right now. You can't just bring the two out front. We have to use product rule, so we have to do first times derivative of the second plus the second times derivative of the first, which would just be a 1. So what this ends up giving me is negative 4x, so I'm taking and rewriting this first term, times 24 minus x squared, or x squared, 24 minus 2x, plus 24 minus 2x squared. Now, there's no easy way to go about solving for this, so what I'm actually going to do is, actually it might be easiest to, now that I look at this a little bit more, pull out a 24 minus 2x. So I'm going to go ahead and do that. 24 minus 2x, pull that out. I'm left with negative 4x plus, I'd have a 24 minus 2x left on the inside. So I took out a 24 minus 2x out of each of my terms. Hopefully that allows me to be able to do this. I never thought about doing this before. This ends up giving me on the inside then 24 minus 6x. So now I can take and set each of those equal to 0. This one will give me x is 12. And this one, 24 minus 6x equals 0, will give me x is 4. So I have two critical numbers on this, and so I want to know which one is the maximum. So I will try the different intervals. And in all honesty, all I really need to try is maybe 8 in here. So if I put 8 in here, I get a positive number because that would be 16, or 24 minus 16, which would be positive. And if I put 8 in here, I have 24 minus 48, which would be a negative. So a positive times a negative is a negative value. That means it's positive over here and positive over there. Because it's a polynomial, I can just jump to those conclusions. So it's increasing, then decreasing, then increasing. So that means that this is my maximum. And that's exactly what I found out in this chart. So I found my maximum was 4. The last thing we want to do is answer this question. So it says use a graphing calculator to verify the maximum volume. So I haven't actually found a maximum value. I know the maximum value from before, but to find the maximum volume, I would plug in 4 into my volume equation right here. So I would have 4 times, let's plug in 4 here, it'd be 16 times 16. And we actually did that back here on the chart. It was 1,024. So my maximum volume is that. I will not be doing the graphing calculator part of that. If you guys want to check that on the graphing calculator, you need to plug this into your y equals equation. You want to find 4, and then you could actually change your window height so that you would see that the answer would be 1,024. I have one more example, but I will show that in one more. Okay, on the last video I got cut off and I cut myself off from that. What I was saying is that I have one more problem left to do, and I'll do that on this video. So this talks about a rectangle being bounded by the x and y axis and the graph of 6x minus, or 6 minus x divided by 2. That really is the equation 6 divided by 2, which is 3 minus 1 divided by 2, which is 1/2 x. So that's this line right here, and it's bounded by the x and the y axis. So there's my rectangle. What we're going to be doing is we're going to be maximizing the area, which is the strategy that we use. We locate what we are going to be maximizing or minimizing first. So we're going to maximize the area. I'm going to come up with the two equations. Y equals, I already have one of the equations that's right here, 3 minus 1/2 x. And then the second equation is the one that I'm supposed to be maximizing or minimizing. So I'm going to maximize this area of the rectangle, which would be x times y, or length times width. I do want this as a function of one variable, so I'm going to replace the y with a 3 minus 1/2 x. And I'll rewrite this as 3x minus 1/2 x squared. Take the derivative of this, allows me to be able to find my critical numbers. So I have 3 minus, this ends up giving me x. So I get, when I plug in 0, 0 equals 3 minus x. And my critical number then ends up being x is 3. How do I know for sure that that's the maximum? The easiest way to do that is by a second derivative test, and I actually haven't done this in the other examples, but I could have done this. I'm just taking the second derivative, and notice that I get -1. That means it's concave down everywhere because the second derivative is negative everywhere. So I know this is concave down, so I know that this has to be a maximum. So the only thing I was supposed to do is find the length and the width of the rectangle, and I've done that. I found the length, and it's 3. What I can do to find the width is just plug in 3 for my x value, and I end up getting 3 minus 3/2. So that makes my y value be 3/2, or 1 1/2.